Algebra 2, Lesson 22, Part A, is about uniform motion problems when the distances are equal. And for this, we use this main formula, distance equals rate times time, which, if you think about that, you already knew that. If you're going 50 miles an hour for 2 hours, you travel for 100 miles, right? You multiply your speed times how long you're traveling. That tells you how much distance you've covered. So that's what this formula is that we're going to be using for these particular problems. And what we're going to do is read the problems carefully, make a list of the information they're giving us, and it will help us to just keep things organized and then be able to solve them pretty simply. So let's just take a look at an example here. Roger made the trip one Sunday. Judy made the same trip one Monday. That means their distances were equal. Okay, because same trip. And then it gives us Roger's speed, his rate. He traveled at 12 miles per hour. Judy traveled at 20 miles per hour, so her time was 2 hours less than his. And the main variables that we have in these equations are d, r, and t, distance, rate, and time. So I'm going to make a list, distance, rate, and time, and I'm going to use a subscript r for Roger, so Roger's distance, Roger's rate, and Roger's time. Alright. I don't know how far he traveled, that's what we're supposed to find out. But I do know his rate, he traveled at 12 miles per hour. Okay, and then we also will do a list for Judy, distance, rate, and time. Subscript is J for Judy. Her rate is 20 miles per hour. Now, her time is 2 hours less than his. So time of Judy is time of Roger minus 2 hours, because her time is 2 hours less. She went faster, so it took her less time. For him, we're just using TR. Okay, and their distances are equal. So I'm going to start out writing Roger's distance is equal to Judy's distance. And then this formula tells me that distance is rate times time. So instead of D, I'm going to put RT for Roger equals RT for Judy. Fill in what I have here from my list. Roger's rate is 12. We're just using TR for his time because we don't know what it is. Judy's rate is 20 and her time is TR minus 2. Then here we distribute 12 TR equals 20 TR minus 40. Subtract 20 TR. I could have subtracted 12 TR, but then everything's on the right side and I have to add 40. This will take fewer steps. These are opposite signs, so I subtract. I get negative 8 TR equals negative 40. So divide by negative 8. Should have written a little smaller. TR is 5, because 40 divided by 8 is 5. They're both negative. The answer is positive. And we're not going to have a negative time. We're not time traveling. We're not going back in time. So that would be Roger's time is 5. Okay, but they want to know the distance. How far did they travel? They didn't ask for Roger's time. But I know that the distance is equal to his rate times his time. And now I have both numbers. So distance is rate, which is 12, times time for Roger is 5. Distance equals 60. And this was miles per hour, so the distance is miles. And that's how it's done. Now you can check it. We did 12 times 5 to get 60. We should be able to take Judy's rate times her time and also get 60. TR is 5. That means Judy's time is 5 minus 2, which is 3. 3 times 20 is 60. And it matches. So we know it's good. Alright, here's another example. If these names look odd to you, these are they're old Brer Rabbit stories. You may recognize that. Brer Rabbit hopped off toward the briar patch at 10 kilometers per hour at 10 a.m. At noon, Brer Wolf began the chase from the same starting point. If he caught Brer Rabbit at 2 p.m., how fast did he run? So sometimes it's helpful to kind of make a little diagram. Here's the starting point. Okay, Brer Rabbit went some distance before Brer Wolf caught up. Okay, so this is the distance of Rabbit. So Brer Wolf started later, but he still covered the same distance because he had the same starting point, like it says. And if he caught Brer Rabbit, then he got to the same point here. So that's also the distance for Brer Wolf. So it's going to be similar to the first one. For all of these that you do for now, they're going to have equal distances. So we're going to be doing a list: distance, rate, and time for Rabbit, and distance, rate, and time for Wolf. Okay, so Brer Rabbit hopped off. Okay, his rate is 10 kilometers per hour. Okay, now Brer Rabbit started at 10 a.m. He got caught, or the wolf caught up at least, at 2 p.m. So how many hours had passed there? Looks like 4 hours, right? So the rabbit's time is 4. The wolf started at noon and caught up to the rabbit at 2, so his time is 2. We don't know his rate. That's what we're supposed to find out. Okay, this is what we're searching for this time. Now, we do know distance equals rate times time. We use that a lot. We already have the numbers for both rate and time for Brer Rabbit. So distance equals 10 times 4, 40. And it's the same distance, so the wolf's distance is 40. We're trying to find his rate, which is his speed. And so we have 40 equals rate of wolf times 2. So divide by 2, and we're getting the wolf's rate is 20. Rate of wolf is 20. Then look back here, kilometers per hour. Okay, 20 times 2 is 40. 4 times 10 is 40. Distances are equal. Looks good. That's all there is to these problems. Okay, practice showing the work. Make the lists and everything now. They will get a little more interesting later. Part B is about similar triangles. You've already been working with similar triangles. We've been doing scale factor. Now there's another way we're going to practice doing these, which is with proportions, which is nice because you're now doing some of those word problems using proportions. And they're very straightforward. So the first thing I recommend still is to redraw these triangles turned the same way. So 2 random triangles that look similar to each other. And I'm going to put the 1 tick mark up here and the 2 tick marks over there. See, it's a very rough sketch. These aren't even technically triangles. I didn't complete them. Between 1 and 2 on this triangle is the 5. Beside the 1 is the x. Beside the 2 is the 4. On the other triangle, between the 1 and 2 tick marks would be the 7. Beside the 2 is the y. And beside the 1 is the 6. Now they're turned the same way, and we can just set up proportions. So let's see, we need to make sure we're using the one where both of them are numbers, and it's nice to keep your variable on top. So for x, I'm going to do 5 over 7 equals x over 6. Okay, left side over left side equals right side over right side. You can cross multiply, or if you've kept your variable in the numerator, you can just multiply both sides by that denominator to get the x by itself. X is 30 over 7, and it doesn't reduce. For y, Okay, again, if I want to keep that in the numerator, I could do, and I still need, oops, I should be looking at that down here. I need the 4 and the y, and the 5 and the 7. But if I want this in the top, I'm going to start with the 7. So 7 over 5, okay, this left side over that left side equals this bottom over this bottom, y over 4. And then, again, I could cross multiply, or I can just multiply by this denominator, so I get the y by itself. Y equals 28 over 5. We're done. That's it. That's all there is to the notes for this entire lesson. I hope you enjoy working on these problems.